And once you finish urban features, the next lesson is called Mitigation Design. This is a brand new lesson, so just doesn't have a video link yet because I haven't created the video yet. So let's see what happens. So I'm going to just kind of try to slow down and go over this a little more carefully, because this is kind of the cool thing about Flow 2D is mitigation design. You can use, or you can set up your mitigation project and then run it and see if it's going to work, digitally before you try to employ it, physically, just to find out that it didn't work, it just caused flooding in other places, or it just didn't work, or whatever. So these projects work pretty good to kind of give you an idea if it's going to work or not, your mitigation. So coastal mitigation practices include improving drainage, identifying critical infrastructure, protecting evacuation routes and evacuation zones, protecting and restoring natural flood barriers. And so we're going to see some of this stuff. We can't cover everything, but we're going to show you how to use QGIS along with the Flow2D plugin to set up some simple mitigation structures. All right, now let's get, okay, so just some ideas. Protect critical infrastructure, raise roadways or apply seawalls or jetties, improve culverts, tide gates, or add pumps, modify base flood elevation for new construction. So your base flood elevation maps, you can study and modify those. Improve basin storage, restore natural flood management, and improve drainage maintenance plans. So we're not going to look at all of these. We're going to look at a handful of them. We have a highway centerline shapefile that we're going to use, a mitigation polygon shapefile, and of course our elevation data. And you can also, use improve elevation rasters as well. So for example, if your mitigation includes some civil 3D design that deals with a lot of like grading changes or new basin elevations or things like that, you can use a mitigation elevation layer too. I don't have one of those though, so we're going to show you some other tools that you can use. All right, so we have these two layers, mitigation polygon and highway centerline polygon. We're going to add those to the map and then color them. Okay, so let's try that. So of course we want to start by selecting our external project data. And I think in this case we may want to turn this back on, but let's wait. Okay, so we come to project data, mitigation, and we can just grab these two shapefiles and drag them onto the map. They're pretty easy to see. That one's pretty easy to see, but I think in the map I tell you to change that simple fill to, let's change that to no brush for that, and then let's change the stroke color. So we don't want to fill the inside, but we do want to fill the outline. And again, I like green or lime green or whatever, so it's just an easy color to see. And let's just change that to 1 and click apply. And so now you can see our polygons over there. And we'll do the same thing with our highway center line, except we'll apply that to the simple line. And let's just change that color to green because it makes it really easy to see, and change the stroke width to 1 and click apply and click OK. So if we turn off some of our Flow 2D stuff, let's see, storm drain, you can see our mitigation and highway center line polygons pretty clearly. If you want to turn that back on or leave it off, it doesn't matter, it doesn't hurt anything, the data doesn't go away, you just are not looking at it, okay? And then we come back here and see what we do next. Okay, next is next we're going to look at some tools to help you identify maintenance plans and things like that and find features. And so we're going to open or load the OpenStreetMap. We're going to, well, we already did this, run the OpenStreetMap downloader, but we'll do it again. And then we're going to open some data connections. Let's do that now. So well, let's see, load the data. So it's basically just using Quick Map Services to load the OpenStreetMap. Now note that this OpenStreetMap is a raster. Okay, so as you zoom in and zoom out, more features turn on. That's pretty cool, but it's a raster. So it's not really useful data. The OpenStreetMap downloader, as you saw, is points and polylines. Okay, so we'll show you how to do that again. And then the final one is open a data connection, which is basically connecting to the data that your organization already owns by loading your ArcGIS online data server. And this is really awesome tool to help you find and manage your own data using QGIS. Okay, so we're going to be loading all of these because I've already built them for you, and I've given them to you in an XML file. All right, let's go ahead and do these things now. So let's start with Quick Map Services. Well, first off, we'll turn off our satellite image and we'll go to Quick Map Services, and instead of loading an aerial, we want an OpenStreetMap standard map. And wait, I messed up. Sorry, where did I put that? I think I put that in here. Yeah, I don't want that in here. I'm going to right click and remove that. And let's get off of that, and we'll come down here and we'll put our cursor right here, or click on this one. And again, with the Quick Map Services, OpenStreetMap Standard. Now you can see as you zoom in, things become more clear, and you can really see a lot of detail in this map. But it is just a raster, okay? So you can use it to find things, and you can use the ID tool on it, but it's not very useful because it's just a raster. So instead, we can use the OpenStreetMap downloader. And this is our project area. And again, with the OpenStreetMap downloader plugin is right here. And then we just draw a rectangle and we save the file. Now, this time we'll put it to Coastal 2D, Project Data, Mitigation, and we'll just call it osmdownload.osm. I've already got one, so let me just overwrite it, okay? Because I've already done this, so let me just overwrite that. And I'll click yes and load the layer and click yes again. And as you can see, it gives you the exact same data as OpenStreetMap, but it limits it to just your area, and it's kind of more useful data. Okay, so you have polylines, points, polygons, and you can turn these things on and off. Let's see, trees, it's got quite a bit of stuff in here that you can turn on and off. And then these guys are streets, and these guys, I don't know what these are, some different kinds of zones. And of course, be careful with this zoom 1, 2, 3. And then there's your polygons. And as you can see, if you zoom out, some of those will turn off, and you zoom back in, and some of those will turn back on. And they are polygons, so they're vectors, so you can do things to them. That's really cool. So we're going to turn that back off. We don't actually need it, so we are just going to turn it off, and we'll just remove it if you want, because we're not going to use it. I just wanted to show you that it's available. And the next one is to connect your QGIS to your personal map server. So there's one for South Florida Water Management District. There's one for the state of Florida. There's one for City of Naples, and there's one for Collier County. And of course, anything that's out there and available, you can connect to it. And it's very easy. You just go to Layer Management. Well, actually, I apologize. I'm wrong. You go to right-click down here, add a group, and we'll call this. Let's see. What would we call this? Let's see. What does the lesson tell us to call it? Open Data Connection. Looks like I'm just adding it to any generic location, so we don't want to do that. Let's Oh, I see why, because it's not actually adding it to anything until you actually start adding the layers. Okay, that's fine. That's perfectly fine. All right, so we don't need to do anything down here yet. So what we do need to do is come up here with layers, add a layer, and we want to do this. We want to add an ArcGIS REST server layer. And sorry, I have a bunch already on here, so let me remove them real quick so that we can kind of start fresh. And what I've done is I have given you like a list of these in an XML file. So if you click the load button and see, let's grab our navigation pane real quick, and you go to Coastal 2D and you go to project data, mitigation, and you see that your open data connection right here. Click open and you want all of them. So this is kind of like your data. And we click import, but it's the your open data, right? It's not just your data, it's your open data. So if you have data that's not open, you can add that too. You know, if you click new, you can add, you name it, you put your server URL and then your authentication, your password and stuff, and you can connect to your own data. All right, let's connect to South Florida Water Management District. And then what I did is I just connected to these structures right here. And you can see it's got the correct coordinate system, and I click add. And then I close it, and you can see that a couple of these structures are in our area. See, we have 3 of those structures in our area. And what's in those structures? Let's do this. Let's select them. So I'm going to select that, and then I'm going to select those 3 structures. Oh, sorry, I'm on the wrong one. Let's get off that tool and get back here, and we'll just select our whole area and then open that attribute table. And where did that go? Okay, it was a lot of data, so it took a while to load. And then let's move the selection to the top to see what we're looking at. So it tells you the expert on that structure and the hydro ID and what it is. So it's COCO 1 or COCO 2 spillway and another weir, and some other information about that is important. You can also load, like I think in here there are like some active projects. So if you come back here, whoops, sorry. If you come back in here and you go back to that layer manager, you can also like filter this, and let's just filter it by project, by the word project. So here's your governor priority projects, maybe some other projects here that you can load. And so of course if you're doing mitigation work, this is exactly the kind of information that you want to load to your map. Okay, so I'll go ahead and add one more and close that. And it looks like there are some projects close to our area, but unfortunately they're just outside of our area. And again, same thing. Okay, let's go ahead and select those. So let's go ahead and select them. And then we right-click Open Attribute Table and move selection to the top. And you can see that we have selected some construction projects. And so you could use these construction projects to build into your mitigation. Like this says aquifer storage. What is this? Reclaimed water. I'm not sure what that is, but you could possibly build this into your map. If it was aquifer storage, I'm thinking that you might do that with some sort of infiltration. I'm not sure how you would do that exactly, but it's something you could do. Anyway, so that's how you would pull in your own data. Now, let's take a look at this modify. So these are the steps that we are going to do some mitigation. We're going to modify Highway 41. And then once we modify Highway 41, it's going to mess up our channel elevation, so we got to reset that. Then we're going to improve a culvert and maybe turn COCO 1, give it a pump, and then we'll save and export. Okay, so modify Highway 41. It says now that some data is loaded and you know how to like load data for your own areas, we can proceed with some simple mitigation changes. The first one will be just to raise Highway 41. And literally could do that by inches, you know, just be like basically like improving the culverts. I'm sorry, improving the highway center elevation, or maybe improving the gutter systems, these kind of things that you can do with elevation modifications. So let's get rid of the data that we don't want, and we will select the data that we do want. And then we will go to collapse the Flow2D widgets and pick up this grid tool. So 5 is collapse the widgets and open grid tools, and 6 is to select this guy right here. And then we are going to use this elevation correction tool, number 6, to choose our layer, choose our geometric predicate, set the elevation corrector, and apply the correction only to the selected field. So this is just a simple way to raise the grid element elevation using a correction feature, right? Let me show you how this works, okay? So first of all, let's select this and right-click Open Attribute Table. So we have some information about this. We have the width of this is the center line of these roads, and this is the width of these roads. Their highway number. I don't have the elevation for this because we don't need the elevation for this. It's going to be a correction. So this needs to be null, and this is going to be +1, or this is going to be +5. So correct one up 1 foot. If you wanted to correct it down 1 foot, that would be a negative value. If you wanted to correct up 6 inches, remember Flow2D uses feet for everything, okay? And then this is the half width of this road. So what we are going to do is we are going to select Highway 41. See, I'm on the select tool, and we are going to apply our elevation correction only to Highway 41. And obviously this is probably something that I don't know that you would even do this correction in this area. It's probably not really necessary, but a highway elevation correction in other areas, like associated with the Everglades or maybe moving water under highways, you could probably use this correction tool in those locations. Let's take a look at this. This is the correct grid elevation tool, and we want to use external layers mode, and we want to use a polyline layer. We're going to choose the highway center line, and our buffer for making our elevation correction would be the half width of the road. Okay, so we have the half width. So if your road is 140 feet wide, you would apply a buffer of half that, because it's going to apply the buffer to both sides of the center line. Our geometric predicate will be set to centroids within the buffer that's going to surround the highway center line of only the selected feature. It's not going to apply it to our other roadways, only the selected feature. And we want to use elevation attributes. So our elevation field, remember, was elevation, but it was null. So no change to elevation. And our correction field will be to correct up either 1 foot or 6 inches. And now I can apply that correction by clicking OK. And what it's doing right now is it is building the buffer. You can't see that, it's invisible. And then selecting all of the grid elements with that buffer, taking their known elevation that they already have and adding 1 foot or 6 inches to it. I think I selected the 1 foot. And then you click OK, and every one of these along the highway will be raised up by whatever desired value you want to raise them by. Now that we've done that, we have to come in here and fix the cells that we didn't want to correct, and that would be these guys along our channel. So now we need to go and select the mitigation polygons, selection tool, and select this polygon. And so we corrected these grid elements right along this line. But I'm going to apply the correction to all of these grid elements in this area. And same thing, we're going to select the correction tool. And this correction tool can do all kinds of different elevation corrections. So if you want to study it, go to the user manual because it's got videos and everything on how to use it. External layer mode. Now we're going to use the polygon layer, and we want mitigation polygon. We don't need anything here. We do need a geometric predicate. Again, centroids within the polygons, not the grids within the polygons. And this one's going to be different. Now we want statistics within the polygons. We want to select it from the raster layer. We want the elevation raster. We want either mean, min, or max. So we can do mean or min, and that will drop our elevation of those down a little bit. Use only selected features, and I don't think this one works, so I'm going to ignore it. And then this is the statistics per grid element. So what it's going to do is it's going to look at the raster, and it's going to take a minimum of all of the pixels within the grid element of any grid element whose centroid falls within the confines of this polygon. So we click OK, and that will apply the grid elevation correction. And then once that is complete, you can, one second, let's let it finish. Okay, once that is complete, you can turn your grid on real quick, and if you zoom in, you can either use this ID tool, which is here, and you can check those elevations and see how they changed, or you can actually turn on the grid element numbers by using labels and using the elevation field, and then you can even apply some like number formatting, like so if you don't want to see the whole number, you can limit it to a certain decimal places, and you can give it a buffer and stuff like that. So you can do stuff like that, and then you click OK, apply, and click OK, and then of course you want to zoom in, and then you can see that those were indeed corrected to the correct elevation, while these were brought up a foot, so these were probably closer to 9 foot in elevation. And then of course to turn that off because you don't want to see that, what you can do is double click it and then just put that back to no labels, or if you're on single labels, you can change the rendering so that it's scale dependent rendering and it will turn off at a certain scale. I'm not going to do that right now. I'm just going to turn it back off and click apply and click OK, and again we'll just turn that grid layer right back off. So that is how you quickly change the elevation of a grid element using 2 different methods. Now let's go here and see what our next thing is. So we did that, modify that, we reset the channel elevation, and let's improve a culvert. So we are going to select culvert 10. Oops, I need to reset that. I think I have fixed that. So let's see. No, I thought I fixed that. Well, we won't worry about it right now. I thought I fixed that to make it say culvert CU10 and change that, but I'm sure it's fine. Okay, so improve a culvert, and we are going to select culvert 10, and we are going to change the culvert width to 5 foot, and we're going to give it 3 barrels. So let's go ahead and grab that culvert, and let's get rid of that, turn that off, and collapse these guys and go to structures and select CU10. And as you can see, let's go ahead and zoom in on it. So we're looking at this one right here. We're going to give it a 5, but we're going to give it 3 barrels, so it's going to be 15 foot will be its effective width. So 5 by whatever its height is, it's 6, and 3 barrels, or of course you would probably change this one too, so it wouldn't be like a 6 foot height. It would be whatever your standard culvert is, but you're just adding some barrels to it. And then you do not have to run the schema tool because all we did was make changes to the tables, and those are automatic. So when we export that, that will automatically be applied to the data because as soon as I make a change and then I click another cell, it's automatically committed to the data in the geo package. Now, what else were we going to do? The next thing, so that's quick, easy way to improve a culvert. The next thing is to add a pump to Coco 1. So let's just say for the sake of an example that Coco 1 is causing some flooding upstream because it's not draining fast enough, because the tide gate, even though it's fully open, is still constricting the flow through the system. So what we can do is add a pump to it to pump more water downstream and push more water downstream. Of course, every time that you add a change like this to your system, you have to recognize that you might just be pushing the flooding onto your downstream neighbors. So you do want to be careful about that. So what do we got here? We have a rating table for this tide gate. It's a weir that is a gated weir. So it has different potentials for rating table, right? It could be a closed gate, meaning that it's controlling the flow by closing the tide gate and not allowing upstream flow and restricting the downstream flow. Or it could be an open gated weir where when you're in the rainy wet season, they open the gates to allow more water to move downstream, and the gates are open but there's still a constriction. So in that case, we are going to add 100 CFS to any depth above 5 feet in our rating table. So that's effectively adding a 100 CFS pump, steady state pump, to our system. And you don't have to change anything, you can just add that table. So let's go here and let's select Coco 1 and let's do a center so we can get to Coco 1. And maybe you can turn our picture back on so you can remind you what Coco 1 looks like. You can definitely see the constriction and the opening is here. And so sometimes that's just too much water in the upstream side of this. It could cause flooding in these neighborhoods, so we need to push more water downstream. I'm going to do that by coming down here and finding our 5-foot depth and then adding 100 CFS to that. Okay, so this one will be 1081.66. So let's just do that. 1081.66. This one will be 1350, and we're just basically giving that 100 plus 100 in every one of these. So 4, 4, 5, and you can do this in a table editor too, but there's so few of them that I'm not super worried about it. 5, and the final one is 6. And it's pretty simple to add a pump to a weir like this. Of course, if your pump is like a larger steady state discharge or a variable, you just build that into the table in addition to what would be going through the weir, on its own. And of course, if you're adding your pump, that might change your I don't know what you call it, your stability, so it might cause a bit of a backwater or something. So that's something to consider as well. And again, we did not make any changes to anything, so we don't have to hit the schematize button because we didn't move anything on here. So we don't have to hit the schematize button, but if you want to, it certainly wouldn't hurt anything. Just to check it, certainly wouldn't hurt anything to hit the schematize button. And that's the last of our mitigation changes. So the final step would be to save and export the project. And let's go ahead with that. I don't think we need to turn any switches on because we didn't make any changes to our switches. So we just do our export. And of course this goes to the project export folder and the mitigation test. And again, let me quickly clear that data because we don't, let's see, project export, let me just delete that. And this one, select folder, and we'll go ahead and, yes, we did click schematize, and yes, we do want to export that. And then don't forget, be careful about this path that's coming up, okay? It's always going to be the wrong path. So make sure you correct that path. And we didn't make any changes to this. Click OK, OK, and maybe one final, nope, I guess that was it. That was the last OK. And of course, we do want to run this one, but I'm already running a model and it's only to hour 16. So I will probably let that model run before I start the next model. And I am running both of these because I want you during the class to be able to create a before and after raster to see the difference of these changes that we made to the map. And let's go ahead and save it, and we will close it. And of course we want to make a backup of that, because if you are out there and mess something up and I have these backups for you, I can just give them to you and you don't have to worry about not being able to continue on with the class just because you made a mistake. So, and that is basically the end of the video, so I will also pause the video and close it down.